We just finished studying how to display one categorical variable using frequency tables or pie charts, etc. What we want to do now is talk about what happens when we actually have two categorical variables and how that will change things. So this data is from the Ralston High School class of 2000. Just kidding, I totally made it up, but it's nice to have some context. So for the white students, it's a primarily white high school that I used to teach for. For the white students, 198 went to four-year colleges, 36 went to two-year colleges, and 4 went to the military. 30 entered the workforce. For the minority students, 44 went to four-year colleges, 6 to two-year colleges, 1 went to the military, and 6 entered the workforce. So how can we make some observations of this data? It's really hard to do that just by looking at this data because, again, we're looking at 198 white students versus 44 minority, so really we're probably going to want to look at percentages instead of raw numbers. So here is one way to display, or one of the best ways, I guess, to display two categorical variables is to make a contingency table. So what this does is it gives me one of my categories here. So this category is obviously post-high school plans. And this category would be race, not very specific, just white and minority. And some columns, or excuse me, some tables do have a total column. So notice I have a total column and I also have a total row. Those are helpful, but keep in mind that you may not get those if you're working on a question. So the key features here are that we do have the marginal distributions, and that's what we're dealing with here. This would be a marginal distribution of plans after high school. This would be a marginal distribution of race. Again, the rows represent the totals. The column represents the totals for post-secondary plans. And then here we can see that we have a total of 322 students. Now, why is this helpful? It's just a way to organize our information to help us answer questions based on conditions. So here are some questions for us to go over together. What % of the students were white? So when I'm answering questions like this, I need to pay special attention to what I believe the population is. And this one says what % of the students, which means out of all of the students, 322, how many were white? That was 268. And so I would take 268 divided by 322 and turn that into a percentage. For today, we're just going to round to the nearest tenth of a percent. If you're working on this for a homework assignment, be sure you pay attention to the instructions. My next question says what % of whites went to the workforce. So here, notice I'm not talking about 322, I'm talking specifically about only white students. That's 268. How many of those students went into the workforce? 30 out of 268. And so notice I can then divide 30 by 268 to find my percentage. What % of students who went to four-year colleges? So now my population, and when I say population, I'm speaking about the denominator of my fraction. So this denominator was 322 because it was all students. This was 268 because it was white students only. So this is the population of students who went to four-year colleges, which I'm going to look for here, 242. What % of those students were minority? So minority students who went to four-year colleges. And that is what I would do for that question. 44 out of 242, turn that into a percentage. What % of minority students? So now I'm speaking only about minority students, and notice I'm just going to be choosing one of these numbers from above. So did not go to college, that would be my military and my workforce people, which is 4 of those students did not go to college. So what percentage is that? About 7.4%. And this last question is just making sure you understand what's a marginal distribution. They're asking for marginal distribution of race as a %. So I'm looking just at these numbers 268 out of 322 and 54 out of 322 turned into percentages. So now that we know how to answer some of those questions by hand, it might be helpful to be able to answer some of these questions by not having to do the math by hand, but by letting StatCrunch do the work for us. So I'm going to take you through in the next 3 slides how to make a contingency table to answer the questions that we've already answered about my data set from Ralston High School. So my first questions I want to focus on would include column totals. So I'm going to look for what percent of students were white and what is the marginal distribution of race as a percentage. So I'm going to go to Stat, Tables, and we've already done this, but before we went to Frequency, now we're going to Contingency, and I'm going to go with Summary. Now, what do I want to use? I want to choose my columns for white and minority, so I just shifted to select both of those. And in this one, for row labels, I'm looking for what their plans are. So plans for white and minority students. I can choose percent of total and compute, and notice what it gives me is a nice contingency table result. How is this helpful to me? Because down here at the bottom, I can see that 83.23% of students were white, and I can also find my marginal distribution, which is the values at the bottom, which is 83.23 and 16.77. So I have just completed answering some questions about the percent of total using my Ralston High School data. Now I want to look at how I might further leverage this contingency table so that I don't have to do any actual math. So looking at this, I have my percent of total, but now I want to answer the question, what percent of white students went to the workforce? And that does not answer this, because if it did, this column down here, the column total would be 100%, and then I could look at these percentages. So I don't want to do any work, so I'm just going to go back to options. Now, if I hadn't already done it, of course, I would go back to Stat, Tables, Contingency with Summary, but since I already have all of this data here, I'm just going to go back to my options and edit, and this is how I would do it if I were actually doing my homework assignment. Notice those are still selected, white and minority, and now instead of percent of total, in this case I'm going to choose column percent, because remember, I want the percent of the column to equal 100. I still included plans as my row label, so I didn't change anything up here. I've only changed column percent and click compute. Now, why would this be helpful to me? Because now I can see out of all white students that 11.2 or 11.19% went into the workforce, which was one of my questions. Another question was what percent of minority students did not go to a college, and here again I would still have to do a little bit of math because I would have to add the 1.85 and the 5.56, but again that would still give me the 7.4% without doing too much work. For my last question, I'm trying to determine the percent of students who went to a four-year college were a minority. And four-year college is a row, and so what I want is for this to be 100% so I can see the percentage breakdown by race. And so I can go to Options, Edit, and then again, instead of column percent, I'm going to do row percent and click Compute. And again, the row percent will give me that out of 100% of the students that went to four-year colleges, 81.82 were white and 18.18 or 18.2 were minority. Now this matches what we did by hand using the calculator. Before we continue, I do want to give you another option, and I don't recommend this, but some people really like it. I can choose row and column and percent of total all at once, and again I find this to be very busy. The advantage here is that I wouldn't have to keep going back into my options and selecting different rows or columns, etc. The disadvantage obviously is that there's so much going on in my table that it might be really difficult to kind of keep straight what's what. So that's another option for you if you want. Notice it does tell me that it's the count and then the row percent and then the column percent and the percent of total. So if you want to do it that way, that's certainly a way that you can go about it as well. Another method for giving that same data besides a contingency table is our conditional distribution. And essentially what this is it's just making separate tables for the condition of, in this case, the condition of race. I prefer the other method that we just talked about with the contingency tables. This just seems like more work to me, but essentially it's taking only white students and finding those percentages, and then only minority students and finding those percentages. And of course then we can use those or that data to compare which students chose what post-secondary option. Which brings us to independence, which is very important, and this week is just sort of an intro. So there is a technical way to determine independence, and I'm not going to teach it to you until we talk about probability in a couple of weeks. So when I ask you about independence, if you talk to me about probability on your assessment, I will know that you have Googled the answer, so please don't be that person. So this week we're just going to look at independence on a very basic level. And essentially what we're asking is, does the condition of your race, so when we're looking at independence, we're looking at 2 or more categorical variables, and we're saying, does one of those variables, I guess I should have written variables, does one of those variables affect the outcome of another variable? So in this case, so usually we're just doing 2. So in this case we're looking at, does race influence post-secondary plans? So these are our 2, race and post-secondary plans. If the race changes, if I choose a different race, do the percentages differ? So looking at my table, I can see that if I'm a white student, I have a 74% chance essentially that I went to a 4-year college, whereas minorities were an 81% chance. Those numbers are not the same. Therefore, we can say that these are not independent. Oh, let me just try that again. Independent. So if they were independent, we would say that the race doesn't affect, that we've got the exact same value for a white student as a minority student, and that is not what we have here. The percentages for 2-year colleges are different. Those are dependent on race. The military percentages, similar but different. Workforce, very different. So what I want you to make sure you understand is we're talking about the whole variable. So some people would look and say, oh, well, military is really close. So for military, it is independent, but for everything else, it is not independent. And that is false. We are looking at the entire categorical variable. So do these change based on which race I choose? The answer is yes, they are different, which means they are not independent. The race does affect your post-secondary plans. So now that we know how to numerically compare data for 2 categorical variables, keep in mind that it's also possible to graphically compare 2 categorical variables. You can do just a simple side-by-side pie chart, which I've shown you here. That gives us an idea of how those color breakdowns or category breakdowns change. I personally really like the segmented bar chart because we're looking at the percent of a whole, and it kind of gives you an idea out of the full population of whites versus minorities what the breakdown was. So I can see visually that fewer minorities went into the workforce compared to white students, that red seemed pretty similar, the two-year colleges, but it seemed like whites went to two-year colleges more often, whereas whites definitely went to four-year colleges less often than minority students. Here's a great extra practice for you. I would like for you to answer the 3 questions that I've given you, and then press play to check your work. So press pause and give all 3 a go first, and then press play to check your work. So looking at question number 1, they're saying what % of passengers and crew survived the Titanic? So this, again, we're always really looking at what is the population. So the population, I got a little crazy with my underlining, is passengers and crew, which is everybody because it's first, second, third class passengers and crew. So my denominator should be 2201, and the numerator would be people who survived. So that would be people who are alive. So my answer would be 711 over 2,201, and then turn that into a percentage. The next question says find the conditional distribution of survivors based on class. So essentially they're saying let's find first class passengers alive out of total, second class alive out of total, third class alive out of total, and then crew alive out of total. And if we do that, again, we're just finding percentages, and we can see that those percentages differ. So what does that tell me? That tells me that overall 32.3% survived, but 62.5% of first class survived, 41.4 of second class, 25.2 of third class, and 24% of crew. So third and crew didn't survive as well as the overall total, whereas first and second survived better than the overall total. So are these independent? Absolutely not. If we thought that the class status was independent of whether or not someone survived, then we would expect to see the same percentage of each class and crew to have survived the Titanic. So obviously this is a no.